Okay, for page 2, number 2, it says to simplify these expressions. Now, we don't know the log rules yet, so the only way to simplify log expressions is to express what's inside as an exponent, which is the inverse function of the log, and have them cancel each other out. So this first one's already kind of done. Log and base 10 exponent are inverse functions, so they cancel each other out, so the answer is just n. This one's a little bit more complicated. We need to express the inside as 10 to the something. Okay, so the first thing we need to do is we need to put these two together into one exponent expression. So we're going to do that by changing the 100 into a common base of 10. So we'll make that into 10 squared, and the first one is 10 to the a. And so the log of both of those two together, we need to combine those into one exponent expression. And remember, if you have two bases, you just add the exponents. And then the log and the base of 10 cancel each other out, and you end up with just a plus 2. What about c? So for this one, we have 10 to the first on top, and we have 10 to the m on the bottom. Remember that if you have a division and you have two bases, then you subtract the exponents, so it would be log of 10 to the 1 minus m. So the log and the 10 cancel each other out, and you're just left with 1 minus m. And let's see, last one on the row. Log of 10 to the a divided by 10 to the b. So this is again a division, so you're going to subtract the exponents, so the inside is going to become 10 to the a minus b. And then the log and the 10 cancel each other out, and you're left with just the exponent a minus b. Okay, now we're going to use our calculator to do some of these. So use your calculator to write the following in the form 10 to the something, 10 to the x, where x is correct to 4 decimal places. Okay, this is just to get you started using the log function on the calculator. The log function on the calculator, you use this button that says log on it, or ln if you're using natural log. So in this case, we're doing log base 10 because if you're trying to find an expression, we're just going to do a, c, and e. Okay, if you're going to make 6 into expression 10 to the something, then let's see, what would that, how would we do that in the calculator? If we take the log of both sides, then you can see that the right side simplifies to x. So actually, x is just equal to the log of 6. Okay? Another way you can think about it is if you think about it with snail rule, 10 to the x equals 6, log base 10 of 6 is x. Log base 10 of 6 is x. Okay? So how would we find the numerical representation of log 6? We would just do log 6, which is 0.7782. Okay, let's do 6,000. So we would just do log of 6,000. Did you notice that the log of 6 is slightly less than 1? Because 6 is slightly less than 10. Log of 6,000, 6,000 is slightly less than 10,000, so it should be slightly less than 4. Okay, yeah, so it should be 3.7, oops, I'm sorry. I should write it as 10 to the something, and the something is going to be 3.778. Because I think it said 4 decimal places. 4 decimal places or 4 significant figures? Decimal places. So that would be 7782. Okay. All right. And E, 0.006. So we just do log 0.006. .006. Negative 2.2218. You might also notice that the last four digits, 7782, are repeated here. So log of 6 gives you 0.7782. Log of 6,000 gives you 0.7782 plus 3. Okay, because the sixth part of it is represented by the 0.7782. And this one is not 0.7782, but if you do 1 minus 0.7782, you'll see that 0.2218 is 1 minus 0.7782. So you see like a numerical pattern there too. Now let's do G. So log of 1500 3.1761. So it's equal to 10 to the 3.1761. And now we're going to do I, which is 0.15. So we do the log 0.15, which is, so the 10 negative 0.8239. Oh, I'm sorry, that was this one, right? Okay, oops. Oops. All right. And, sorry, this computer getting a little old, a little slow. All right. Use your calculator to find the log of 3 and log of 300. Okay, so we'll do that first. Log 3 and log 300. So log of 3 was 0.4771 and log of 300 is 2.4771. Okay? Explain why the log of 300 is equal to the log of 3 plus 2. So if we substitute in 2.4771 for log of 300 and we substitute 0.4771 into log of 3, we can clearly see that that's true. But how do we explain why that's true? Well, let's think about these log numbers as exponents of power of 10. So if we say, okay, what is 10 to the 2.4771? And what is 10 to the 0.4771 plus 2? So this, of course, is 300, right? It's another way of writing the number 300. And of course, this is 2, but do you see how we could break this up? We could say 10 to the 0.4771 plus 2 is equal to 10 to the 0.4771 times 10 squared. And we multiply it because, remember, from last chapter, if you have the exponents added, it is the same thing as multiplying them with each having a base of 10. So, and 10 squared, of course, is 100. And 10 to the 0.4771, of course, is 3. So 3 times 100 is 300. Okay? We can do the same thing with subtraction. So log of 5 is equal to 0.6990. And 0.05 is negative 1.3010. So when they say log of 0.05 is equal to log of 5 minus 2, we can substitute those numbers in. 0.6990 minus 2, and log of 0.05 is negative 1.3010. If we do that subtraction, we can see that's true. So why is that true? Well, remember, if we represent this as powers of 10, we can see that actually 10 to the negative 1.3010, which is equal to 0.05, is equal to 10 to the 0.6990 times 10 to the negative 2. And 10 to the 0.6990 is 5, and 10 to the negative 2 is 0.01. So we can see that 0.05 is equal to 5 times 0.01. And in terms of log, we basically just subtract the exponents to give us the log of 0.05. Okay, so just like in the investigation, we saw that the multiplication operation with regular numbers is addition or subtraction in the log numbers. Okay, let's do the last section. Find x if the log of x is equal to 2. So the key to this is rewriting it as an exponent because it's a little bit easier to understand. And then we'll know how to use it in the calculator. Okay, so we're going to do just the odd ones here. And so for log x equals 2, there's two ways you can think about. One is snail rule. So you could say, okay, if I use snail rule, this will be 10 to the squared equals x. So I could write 10 squared equals x. So I can easily see that actually x is equal to 100. And the other way you could do it is you could do the inverse function of both sides. So if I do 10 to the log of x and 10 squared, if I do 10 to the whatever for both sides, then I can see that these cancel out, so x is equal to 10 squared. So either way, I'll get x is equal to 100. What about C? Log of x equals 0. So if I use snail rule, it would be 10 to the 0 equals x. 10 to the 0 equals x. And remember, 10 to the 0 is 1, so x is equal to 1. The other way I could do it is I could do 10 to the log x is equal to 10 to the 0. And here I can see that x is equal to 10 to the 0, which is 1. Right? Either way is fine. What about E? So here I can see log of x is equal to 1/2. If I wanted to express this as an exponent, I would say 10 to the 1/2 is equal to x. So x is equal to 10 to the 1/2. That is equal to the square root of 10. If I did that on the calculator, it would be 3.16. Log x equals 4. So basically, that would be 10 to the 4 is equal to x. So x is equal to 10. What would it be? 100,000? 10,000. 10,000. Okay. 10,000. And I. Log of x is equal to 0.851. That's another way of saying 10 to the 0.851 is equal to x. So x is equal to 10 to the 0.8351. By the way, if you look in the formula booklet, it gives you this relationship. It writes out this relationship as something like log base a of b is equal to x, and then right next to it, it says something like a to the x equals b. And it says that these are equivalent. So even if you don't like snail rule, if you just look at the formula booklet, it tells you how to rearrange the a, b, and the x so that you can write it as an exponent, because we're a lot more used to understanding exponent expressions than we are log expressions. Okay? If we wanted to find a representation of that, we could use the calculator to do 10 to the 0.8351. While I'm at it, I can find the square root of 10. It would be 10 to the 0.5, 3.16, right? So this would be 6.41 if I want another digit. Okay, remember on the exams we just need 3 significant figures unless they otherwise tell us. So this one here we could rewrite as an exponent if we wrote 10 to the negative 1.378 is x. So x is equal to 10 to the negative 1.378. If we put that in the calculator, 10 to the negative 10 to the negative 1.378. Let's see, it would be 0.04188. Okay, so that's K. And I think that we've done them all, right? So that was page 2.